dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of audio as well as video. If it is perfect, just write perfect over the live chat and then we are going to go ahead. Anyways, let me briefly discuss about the agenda behind today's video. We are going to discuss about the concept of gain margin as well as phase margin. And as far as this topic is being concerned, it had been a very important topic, whether you belong from the electrical, electronics or instrumentation. Anyways, before going into the numerical problem based on the concept of gain margin as well as phase margin, let me briefly discuss about its basic concept. What does it mean by the gain margin? My dear friend, the name itself is self-explanatory. How much margin we had over the gain before the system reaches to the verge of its stability or instability. What I assume? We assume the system had been a stable system, and let's take the gain K had been keep increased, and after certain amount of time the system becomes an unstable system. So the verge of stability, when we reach how much gain we can provide in terms of K, it's been said to be the gain margin. Similarly, what does it mean by the phase margin? The margin in phase. Earlier we had the margin over the gain, and now we had been talking about the margin in phase. And one of the best thing regarding the gain margin as well as phase margin, so far we were doing the stability analysis using the Rauthour weights. We were doing the stability analysis with the help of root locus. There the relative stability was not known. What does it mean of it? Let's take the n number of systems you have. Out of n number of systems, the 4 number of systems are being the stable system. You will not be able to figure it out of the 4 number of stable system, which system had been more stable system and which system had been the lesser stable system. That means the relative stability had not been known so far, but now the gain margin and phase margin had been the basis on which at least I can categorize out 4 number of stable system which is gonna be the more stable system, and end of the day we are going to exploit that system which is going to be more stable system. Could you really understood what had been? Okay. Perfect. So let me briefly discuss few of the important points. I would not go into detailed analysis because the complete concept had been dealt with the questions. So definitely I would take few number of questions and I would try to nurture all of the important concepts which are required behind the gain margin as well as phase margin. So the first important point was like the name itself has been quite self-explanatory. It's been the margin in gain. It's been the margin in gain. Margin in gain, such that the system reaches to the verge of instability. If you provide margin greater than the gain margin, the system would become an unstable system. But one more thing should be there in your mind. Whenever you had been talking about the gain margin, no, you should not introduce any of the phase shift within the system. No. While calculation of gain margin, only and only the introduction in gain can be taken place, but you cannot introduce any of the external phase shift. Anyways, from where this complete concept or the definition had come out, definitely once we will take the few number of problem, you would be able to understand each and everything. And at the same time, if we'll talk about the phase margin, what does that mean by the phase margin? How much margin had been left out in terms of phase? And keep in mind, the phase could be leading in nature or lagging in nature. Here at least in phase margin we talk about the margin in terms of lagging phase. So here goes the phase margin. So here I say it had been the margin in phase, how much we can provide, and this phase margin is being in the terms of lagging. How much phase lag we can introduce within the system such that system reaches to the verge of its stability or instability. And the same concept is also being true. Earlier, in case of gain margin, I was not able to introduce any of the phase shift, and similarly while calculation of the phase margin, I should not be putting or I should not be giving any of the gain within the system. I should not be giving any gain of the system. Could you understand? May I know if the gain is high, the system, would it be a higher stable system or would it be a lesser stable system? Obviously, sir. The margin in gain had been higher, so obviously, sir, I would be categorizing that system as a higher stable system. Similarly, if you had a good amount of margin over the phase, would it be a stable system or would it be a lesser stable system? Obviously, sir, I would be categorizing that system as a higher stable system because I have got a good amount of cushion over the margin in phase. Obviously, sir. So what I am saying, end of the day, the gain margin and phase margin had been the two important criteria on basis of which I can judge the system had been higher stable system or the lesser stable system. My dear friend, when we calculate the gain margin, no, we used to take the reference of phase crossover frequency. Why so? Once we'll take the numerical, you yourself would be able to analyze each and everything. And similarly, when we calculate the phase margin, no, we used to take the reference of gain crossover frequency. So overall in this topic, the 4 different important terminologies are being used, and which would be used frequently here and there in the different questions. The first is going to be phase crossover frequency. The second is going to be the gain margin. Third is going to be the gain crossover frequency. And similarly, the fourth is going to be phase margin. So what I'm saying here, it had been phase crossover frequency. Phase crossover frequency. Over frequency. And here it had been gain crossover frequency. Gain crossover frequency. So lump sum, you are going to study the 4 different terminology, 4 different words within the concept of the gain margin and phase margin, which starts from phase crossover frequency, goes to the gain margin, goes to the gain crossover frequency, and comes down to the phase margin. Comes down to the phase margin. Agreed? So till this point, probably each and everything must be to all of us. All of us. Yes? Let me do one thing. Let me straight away go into the first question of the day, and we would try to learn the concept through the question itself. So here goes the first question. Here goes the first question. Yeah, here goes the first question. Read this problem carefully, and the student who had a little bit idea about the gain margin and phase margin probably must be able to know what would be the exact value of the phase margin for this given open loop transfer function. This given open loop transfer function. This has been the first question of the day. This has been the first question of the day. Tell me how much phase margin this system do carry. How much phase margin this system do carry. So let me start with its solution. The solution do start from here. Let me draw the polar plot for the given OLTF, and that had been 10 divided by S into S plus 10. Obviously, the initial angle is going to be minus because of the presence of 1 upon S, and at the same time, the magnitude at omega is equals to 0 is simply going to be infinity. That means taking the reference of minus 90 degree line, taking the reference of very high magnitude, the magnitude would be keep shrinking, and as the omega reaches to infinity, the final angle is simply going to be minus of 180, and at the same time the magnitude is simply going to be infinity, because all of the factor of the omega has been there towards denominator side. Could you really understood what exactly I wanted to communicate through this? So what we have been doing over here, let me take a polar graph paper. This has been a polar graph paper. Let's take, this has been the 0 degree line. This has been minus 90 degree ray. This has been minus 180 degree ray. And similarly, this has been minus 270 degree ray. Minus 270 degree. And this, if you want, can write as a minus 360 degree ray. Minus 360 degree ray. Now, if we'll talk about this, see what had been happening over here. Its starting angle is going to be minus 90 and the magnitude is going to be infinity. And as the value of omega would be increasing, what would happen? All of the factor of omega had been towards downside. It would be keep shrinking. Magnitude would be keep shrinking. That means the point would be coming nearer to the origin. And at the same time, the final angle is going to be minus of 180 degrees. So it is sort of this. Although I did not draw the exact plot of the polar plot, where I can also draw how the tangent would be at omega is equals to 0, which we have dealt earlier. Agreed, no? Agreed what I am saying? See, if we talk about stability, my dear friends, I repeat, when we talk about the stability, definitely the Nyquist plot has to be extracted from the given polar plot. So this has been the first section of the Nyquist plot, where the omega starts from 0 and goes till infinity plus. So I can write the omega starts from 0 plus and goes till infinity plus. This has been the location of omega, where the omega had been infinity plus. Similarly, if we'll talk about the second section, which starts from omega is equals to infinity plus, goes till infinity minus, obviously it had been overlapped at this point itself. The detailed analysis is already been done in the last class. And now if we'll talk about the separation between 0 minus and 0 plus, definitely there would be the separation between 0 minus and 0 plus. And at the same time, the third section, that used to be the inversion of the given polar plot itself. This has been the polar plot. You will be taking its inversion, and once you take its inversion is sort of this. And here you would be having omega is equals to of 0 minus. Omega is equals to 0 minus. May I know how much magnitude it will be? at 0 minus, the magnitude is simply going to be again infinity. The angle would become minus 270. May know 0 minus and 0 plus how they would get connected. They would connected clockwise in direction, and at the same time they had to travel all the way 180 degree. They had to travel all the way 180 degree. 180 degree. All the way they had to travel 180 degree. Now what they had been talking about, just try to understand what they had been talking about. Forget about the gain margin and phase margin. First tell me the system had been a stable system or whether it had been an unstable system. I repeat, the way the Nyquist has been drawn over the digital board, just watching this given Nyquist plot, can you infer the given system had been a stable system or an unstable system? Forget about the gain margin and phase margin. First tell me whether the system has been a stable system or an unstable system. I would like to have that input from one of you. It had been a stable system or unstable system? Stable system. As per the DS, it had been a stable system because we would be talking about the encirclement of a critical point, and for the closed loop stability, the critical point had been minus 1 plus J0. Did we have any of the enclosement? No, sir, I did not have any of the enclosement. If you don't understand, do one thing, draw a ray which had been originated from minus 1 plus J0, and if we'll talk about the number of intersection over the Nyquist plot, I did not have any of the intersections, so at least in this problem the value of n had been 0. And as far as the stability using the Nyquist plot is being concerned, it's been written as a n is equals to of p minus of z. N had been 0, just try to understand, n had been 0 at least in this case. What had been p over there? The p is what? P is nothing but the number of open loop pole which had been kept towards right hand side of the S plane. There had not been any of the open loop pole which had been kept towards right hand side. So obviously, sir, the P is simply going to be 0. Now here, the closed loop pole towards right hand side that had been Z had been 0. Obviously, it had been a stable system. It had been a stable system. Now, they had been focusing over the phase margin. What I am saying, they had been focusing over the phase margin. My dear friend, if I would start giving the lag to this system, if I would start giving the lag to this system, do you think that after certain amount of time, this minus 1 plus J0 would get encircled? The answer must come in a form of yes or no. The answer, answer would come in a form of yes or no. Answer should come in a form of yes or no. What I am saying, we had been keep pushing the lag into this system, whether the minus 1 plus J0 is going to encircle after certain phase lag. Yes, sir, it had been. Why so? Because the magnitude had been infinite. If you will be keep, what I am saying, if you will be keep rotating it, no, if you will be keep rotating it, if you want, I can just rotate this out. Just a minute. If it is possible, we'll see that how can we rotate this. A minute. No, I think it's not possible. Just a minute. Just a minute. Yeah. See, it had started rotating from its place. See, it had started rotating from its place, and as the rotation is being started, no, see, you yourself would be able to understand. As the rotation is being started, you yourself would be able to understand. Earlier, there was no problem with the encirclement, but now minus 1 plus J0 is going to get encircled. And as minus 1 plus J0 is going to get encircled, in future the system may become an unstable system. The system may become an unstable system. Still, system had been a stable system because although the lag had been added into the system, but still minus 1 plus J0 has not been encircled. What we could have done over here, just a minute, what we could have done over here, just a minute, yeah. We could have taken more phase shift. We could have taken more phase shift. Just a minute. We could have taken more phase shift like this. Like this. Like this. And end of the day, you might be able to understand the minus 1 plus J0 is going to get encircled somewhere. Could you really understood what does that actually mean of phase margin? How much phase you can provide in terms of lag to the system such that the system reaches to the verge of this stability. And when the system reaches to the verge of this stability, definitely this Nyquist plot is going to get intersected to the minus 1 plus J0. And if you take further lagging, in that case, what would happen? Minus 1 plus J0 would get encircled. So far, it had not been encircled. How much phase lag you can provide? How much phase lag you can provide? My dear friend, I would like to have the input from each one of you. Could you really understood the concept or the crux behind the phase margin or not? If you did not understand the basic concept or the crux behind the phase margin, you can put it over the live chat. I would try to explain once again. So we had been providing the lag to the system, and we just wanted to know how much lag we can provide to the system. The system remains still a stable system. Agreed? No? So may I know? Yes, understood. Only one input I am getting now. That input is being coming from the DS. Anyone else apart from DS? Anyone else apart from the DS? So I would like to have the input from each one of you. For this given problem, the phase margin, would it be infinite or would it be a finite value? Obviously, sir, it would be finite value, as the magnitude had been infinity. If you will be keep rotating in the clockwise direction, obviously because we have been providing the lag, after a certain amount of time, what would happen? This curve would get shifted to this, and it would start going through the -1 plus J0. The system would reach to the verge of instability, and hence I can say the margin in phase had been finite in nature. Margin in phase is been finite in nature. Margin in phase has been finite in nature. How will you get to know about it? My dear friends, see, just try to understand how the phase margin would be calculated. Phase margin would be calculated. The phase margin is equals to 180 degree plus of angle offered by the system, Gj omega, Hj omega, at omega is equals to of omega GC. Keep in mind, when we calculate the phase margin, no, we take the reference of gain crossover frequency. We take the reference of gain crossover frequency. And similarly, when we calculate the gain margin, I used to take the reference of phase crossover frequency. Why so? Why so? Why we used to take the reference of omega GC? My dear friend, if you do not have a valid omega GC, no, if you do not have a valid omega GC, that means at any moment of time, the magnitude offered by the system does not reaches to 1. And if the magnitude offered by the system does not reaches to 1, that means at never moment of time it would be crossing through the -1 plus J0. System would become a utterly stable system. After taking few number of numericals, you would be able to understand each and individual critical points which had been inherited by the concept of the gain margin as well as phase margin. Gain margin as well as phase margin. Could you understand what I am saying? Could you really understood what exactly we had been talking about? So what you had to do? You had to talk about omega GC. Omega GC you had to find, then you had to find the angle, and then you had to find the phase margin. What does that mean by the omega GC? Omega GC is nothing but the frequency at which the gain offered by the OLTF, that had been Gj omega, Hj omega, precisely becomes unity. Yes, precisely becomes unity. So what you will do, you will take its magnitude. Once you will take its magnitude, numerator remains 10. Towards denominator side, once you will take the magnitude of S, that's the omega itself, and here it becomes omega square plus of 100, and at omega is equals to of omega GC, the magnitude is simply going to be 1. So I think I would say the calculation of omega GC is your effort. You have to do it in your home. What you can do, you can just shift this component towards right hand side, and then remaining component is going to be much easier. I think it's not a difficult question to deal with. If you want, we can do it by our own. And once we are done with that, you would be calculating the phase margin, and that would be 180 degree. The angle offered by this system is being, because of S, this would be -90, and because of S plus of 10, you would be having 10 inverse of omega, and the omega is going to be omega GC divided by of 10. And once you will do all stuff of calculation, the answer which we are supposed to get, it's going to be somewhere 84 degrees. So this much angle we can provide as a lag such that the system would be a stable system. Sir, omega GC, the magnitude of transfer function will be 1. Yes. Magnitude of the transfer function would become 1. So I would like to have the input from each one of you. The agenda behind this complete problem had been clear to all of us or not? Tell me yes or no. And if I'll talk about gain margin which had been offered by the system, may I know what would be the gain margin which would be offered by the system? I would like to have the input from each one of you. What would be the gain margin which would be offered by the system? Because in this problem, they had been categorically talking about the phase margin. They had not been concerned over the gain margin. But now, let me focus over the gain margin also. Tell me what would be the gain margin over here. Tell me what would be the gain margin over here. I would like to have the input from each one of you. What would be the gain margin over here? See what had been happening over here. What had been happening over here. What does that mean by the phase margin? How much phase lag we can introduce into the system such that system reaches to the verge of its stability or instability. If we'll talk about gain margin, how much gain we can pump into the system such that the system would reach to the verge of the instability. My dear friend, if you had been keep pumping the gain, what does that mean by the pumping the gain? Here you had the 10 divided by s plus of 10, no? So rather than having 10 divided by of s into s plus 10, you could write this as 10 times of k divided by of s into s plus 10. And you had been keep raising the value of k in positive real sense. And in that case, what would happen? Obviously, it would be keep expanding. And as it has been keep expanding, the structure would be more and more bulgy. Like this. The structure would be more and more bulgy. Just a minute. Would be more and more bulgy. I would like to have the input from each one of you. As the value of k is being keep increasing, whether the minus 1 plus j0 is in danger, that in future, whether it can get encircled or it won't get encircled at any cost, whatever the value of k might be. No sir, it won't be encircled at any cost. Because if you will be keep increasing the value of k, is still at omega is equals to infinity, the magnitude is going to be 0. All the way, whatever the large value of k we had, minus 1 plus j0 is not going to get encircled. What does that mean of it? That means the margin in gain is being infinity, whether you keep k is equals to 2, whether you keep k is equals to 5, 10, 50, or maybe 100, at any cost, minus 1 plus j0 is not getting encircled. The system is always been a stable system. Could you really understood what I am saying? I know many of the students, what they would do, first they would calculate the phase crossover frequency omega PC. And they would say, sir, the valid omega PC has not been valid for this particular problem, and hence the value of gain margin is simply infinity. That is not the correct way to smash the problem related to the gain margin. Just feel like the gain margin is being the margin in gain, how much gain we can pump into the system such that the system had been a stable system but reaches to the verge of the instability. That means if you will provide the gain more than that value, the system would become an unstable system. But here, there had not been any chance at all. Could you really understood what I am saying? So as far as this problem is being concerned, when we had been dislocating the complete plot in the clockwise direction, because we had been offering the lagging in the system, after certain lag, the system had become an unstable system. How much lag we can provide to that system is nothing but the phase margin. This much margin in phase we had. We can derive from where this formula had been deduced. But I think for crash course is not required. In the full course, definitely I would be talking about those things also. Now, if we'll talk about this, here we had been talking about the gain margin. What does that mean by the gain margin? Gain margin is nothing but how much gain we can provide to the system until and unless the system reaches to the verge. I can provide infinite gain. May I know, can I feed negative real value of k? I would like to have the input from each one of you. I have taken only and only all possible positive values of k. Can I take the negative value of k? Yes or no? The answer should come in a form of yes or no. I would like to have the input from each one of you. The answer should come in a form of yes or no. Can I have the negative value of k? Yes or no? Can I have the negative value of k? Yes or no? Can I have the negative value of k? I would like to have the input. Your reply would be yes or no. No, I can't keep the value of k as negative real value, because once we keep k as negative real value, see, the magnitude could be greater than 1 or could be in between 0 to 1. But one thing is being quite sure, as the negative term is being associated. One thing is being quite sure, now the system had been introduced a further phase shift. And one thing is being quite sure, when we were discussing about the definition of the gain margin and phase margin, it had been clearly communicated. When we calculate the margin in gain, I would not be able to introduce any of the phase shift, and at the same time, when we calculate the margin in phase, I should not be providing any of the gain. And if you take the negative value of K, that means you had been providing the gain as well as phase shift, which is not permissible, which is not permissible. Which is not permissible. So what I'm saying, this sort of problem, if had been asked in the problem, no, I think use the concept of Raut orbits. Whenever they had been talking about the gain margin, no, you need not to use the polar plot, you need not to use the Nyquist plot, you need not to calculate the phase crossover frequency, just use the concept of Raut orbits, and with the help of that Raut orbits, you would be easily able to get the value of the gain margin itself. See what I am saying? Anyways, we had been talking about the concept of closed loop stability. That is why the critical point has been chosen as -1 plus J0. May I know, in case of Raut orbits, the input used to be the characteristic equation. Definitely taking the reference of this OLTF, easily I may be able to get the characteristic equation. What's going to be the characteristic equation? It's simply going to be 1 plus GSHS is equals to 0. Here it used to have the multiplication. S square 10 times of S plus of 10K is equals to 0. 10K is equals to 0. And now let me draw the Raut orbits table. Here it goes S square, here it comes S, and here it lands up to the S to the power of 0. S to the power of 0. Let me feed the data over here. It had been 1 over here, it had been 10, here it had been 10K. And the last data has been 10K. If we'll talk about the stability, if we have ensured the value of K is being greater than 0, no, there had not been any sign change over the first column of the Raut orbits. That means the system remains a stable system. Whether you keep K is equals to 10, 20, 30, 50, 100, 200, 3000. So what I am saying, whenever in problem they had been talking about the gain margin, forget about the Nyquist plot, forget about the polar plot, forget about the phase crossover frequency, just use the concept of Raut orbits, and from there easily you would be able to get the gain margin. And the gain margin has been simply infinity. What had been the gain margin over here? The gain margin is being simply infinity. The gain margin is being simply infinity. So till this point, if you guys are having any sort of doubt, you can put it over the live chat. Otherwise, we would move forward. Tell me. If you guys are having any sort of doubt, you can put it over the live chat. Otherwise, we would move forward. Let me take the next question. And the question has been GSHS. This has been the design question. GSHS is equals to of 1 divided by of S plus 2. May I know what would be its gain margin and what would be its phase margin? What do we expected value of the gain margin and phase margin? This OLTF do carry. What would be its gain margin as well as phase margin? I would say stick to your basics. First draw the polar plot and then the extension of the polar plot, and that had been the Nyquist plot. May you know what would be the initial angle? The initial angle is going to be 0 degree, and as the omega would increase, definitely magnitude would be keep shrinking, and at the same time the angle would be more and more lagging, and as omega reaches to infinity, magnitude offered by the system would become 0, and the angle offered by this system is simply going to be minus of 90 that we have seen earlier. So it would be sort of this. And at omega is equals to 0, S is going to be 0, and the magnitude is simply going to be half at 0 degree line or 0 degree ray. And at the same time, when the omega reaches to infinity, the magnitude becomes 0. That is why it had been submerged over the origin, and it would take the reference of minus of 90 degree. Agreed, no? Now, let me complete this plot, and that had been the extension of the polar plot. We call it Nyquist plot. So here goes the Nyquist plot. This has been the location of omega 0 plus. This has been the omega infinity plus. And as it had been a proper transfer function, omega infinity plus and infinity minus would be at same place. There would not be any existence of the segment 2. And similarly, here it goes. Omega is equals to of 0 minus as well as 0 plus would be at same place. Why so? Because it had been type 0 system. There had not been any open loop pole which had been kept over the origin over the S-plane. Tell me, what would be the gain margin as well as the phase margin which we can have over this system? Go ahead with the definition of the gain margin. How much gain we can provide to the system such that the system reaches to the verge of the instability, or simply I can say crosses through the minus 1 plus J0. Minus 1 plus J0. If we'll be keep giving the gain over here, no? So what we can do, just to understand the thing in the better way, I could have taken GSHS is equals to of K times of 1 divided by of S plus 2. And as the value of K would increase, what would happen? It would be keep expanding. But all of the part would be expanded towards the first as well as fourth quadrant only. So what I'm saying, like here the K was 1. Here the K was 1, the intersection point over the 0 degree is been 1 by 2. Let's take the K had been increased to 2. As the K had been increased to 2 at omega is equals to 0, the intersection point would be at 1, but still would be at 0 degree. It would be sort of this. It would be sort of this. What I'm saying, it would be sort of this, like this. Agreed, no? It would be sort of this. Yes, we can agree on that. But what had happening, as the value of K is being keep increasing, let's take here the K had been 1, here the K had been 2, the K had been 3, 4, 5, 6. All of the Nyquist plot is going to be towards right hand side only. It's going to be towards right hand side only. Agreed what I'm saying? So one thing has been quite sure. If we'll talk about how much gain we can provide it to the system such that the system reaches to the verge of the instability, my dear friend, the gain is being infinity. How much gain you want to give, you give, the system would never be unstable. Would never be unstable. Could you really understood the thought process behind this complete analysis? In gain margin, I would not be allowed to provide the phase shift at all. And similarly, here goes the phase margin. Here goes the phase margin. Again, let me take the reference of the polar plot and then the extension of the polar plot, and that had been the Nyquist plot. That had been the Nyquist plot. So this has been sort of this. It would start from half, and here it would land up to like this. It had been omega is equals to 0 plus, and even this has been the place of 0 plus also, because it had been a type 0 system. This has been the location of omega is equals to of infinity plus as well as infinity minus. May I know what had been the radius of it? This has been half. This has been half. And now what you have been doing over here, rather giving the gain, you had been giving the lag to the system. And as you would start giving the lag to the system, what would happen? It would be displacing from its place. May I know whether the minus 1 plus J0 would get encircled at any cost? No, sir. Because the maximum radial length itself is been half. If it is been rotated 180 degrees, still it would be crossing through half only. It would be crossing through half only. It would be crossing through half only. So if you are not able to understand what we are going to do over here, let me copy this out and let me start giving the lag now. Let me start giving the lag now. See? Let me start giving the lag now. See? I have started giving the lag now. Even if I give the lag of 180 degree now, like here I have given the lag of 90. Let me do one thing. Let me give the lag of 180 degree. Let me give the lag of 180 degree. See? 180 degree lag is being given. 180 degree lag is being given, but still minus 1 plus J0 has not been encircled. That means how much phase lag we can introduce to the system such that the system reaches to the verge to the instability, I would say, sir. You can provide 180, 270, 360, 720, whatever you can provide, but still minus 1 plus J0 is not going to get encircled. The system would remain a stable system. So obviously, if we'll talk about the margin in phase in this problem, so obviously the margin in phase is simply going to be infinity. Margin in phase is simply going to be infinity. I think it's right time to take the next question. This question had been based on the concept of DC gain, which we have studied earlier. So let me leave it here itself. Let me focus over the question number 3. This question had been experienced by the electronics people in year of 1999. The problem was framed by IIT Bombay. Let me bring this problem towards working world. So here goes the problem. Here goes the problem. The gain margin of the system having the loop transfer function GSHS is equals to of root 2 divided by of S into S plus 1 is. The 4 different options were given along with this problem is being A is being 0, B is been 3, C is been 6, and D is been infinity. Tell me what would be the best most answer for this given problem. How much gain we can provide to the system such that the system reaches to the verge of instability. Anyways, it had been a type 1 system. And similarly, order 2 system. So what's going to be the initial angle? The initial angle is going to be minus 90. And similarly, what's going to be the final angle? The final angle is going to be simply and simply minus 180 degree. That had been the polar plot. Once you'll extend the polar plot in a form of Nyquist plot, so the curve remains very same as we had probably in last to last question. And one thing has been quite sure, if you will be keep providing the gain, it would be keep expanding towards the first as well as fourth quadrant, but is still minus 1 plus j0 is never going to get encircled. Minus 1 plus j0 is never going to get encircled. That could be the first methodology. So what I'm saying, forget about the mathematical process where we calculate the phase crossover frequency and then we get the gain margin. That we would deal after some amount of time, but here focus over the basics of the gain margin and the phase margin. So here we had taken a polar graph paper. This has been 0 degree ray, this has been minus 90 degree ray, this has been minus 180 degree ray, and this has been minus 270 degree ray. And as far as the polar plot is being concerned, the polar plot is starting angle is minus 90, final angle is minus 180 degree. Here it starts 0 plus, here ends up the infinity plus. Infinity plus and infinity minus would be at same place. We have studied about it, and you would be having an inversion of the polar plot that used to be segment number 3, and here it goes to 0 minus. The 0 minus and 0 plus had been settled at two different places. They would be meeting with a infinite magnitude of radius, that's the first thing, that would be clockwise in nature and would take precisely 180 degree. 180 degree. Yes, if you start from here and you go till this point, obviously the total angle which had been taken is simply going to be 180 degree. Is simply going to be 180 degree. May I know the system is going to be a stable system? Obviously, sir, system is going to be a stable system. If you keep providing the gain, sir, still minus 1 plus j0 will never be encircled, and if it is been happening, so the system would remain a stable system. System would remain a stable system. There would not be any doubt as such. So may I know what had been the best most answer? The D is going to be the best most answer. D is going to be the best most answer. Yes, sir. We can understand it very well. We can understand it very well. Yes, sir. The D had been infinity. You could have taken the different methodology. You could have used the second method, and that had been Routh-Hurwitz method. Routh-Hurwitz method. And as per the Routh-Hurwitz method, we would be taking the characteristic input or the characteristic equation as an input, and there it becomes s square plus of s plus of root 2. And now, rather taking root 2, I have taken this as a k, root 2 of k is equals to 0. Again, if we'll make a Routh-Hurwitz table whose first row has been dedicated towards s square, then s to the power of 1, and the last is going to be s to the power of 0. May I know what are the data we are having? Here we are having 1, here we are having 1, here we are having root 2 of k, and here also the root 2 of k would get repeated. Root 2 of k would get repeated. Root 2k would get repeated. Yes, sir. Yes, sir. Now, end of the day, what had been happening? If we'll talk about the positive value of k, for all positive value of k, there had not been any sign change in the first column or the principal column of the Routh-Hurwitz, and hence there had not been any of the closed loop pole which had been kept towards right hand side for the positive value of k. So may I know what could be the margin in k? There is a tremendous margin in k. Whatever the value of k you want to take, you can take. Put together, the gain margin is simply going to be infinity. Gain margin is simply going to be infinity. Gain margin is simply going to be infinity. But lage haath, now what we are going to do next? We had been talking about the phase margin. Phase margin. Because in this problem, we are going to have a finite phase margin, unlike the infinite gain margin. See why I am saying we are going to have a finite phase margin? Because in future, the lag in this system would be provided, no? After certain lag, no, minus 1 plus j0 would start getting encircled. So the moment at which this polar plot crosses through the minus 1 plus j0, we would calculate the angle offered by the system, and that angle would be added with a 180 degree, and end of the day, we would be getting the how much phase lag we can provide to the system such that system reaches to the verge of the instability. So let me do one thing. Let me introduce the another problem within the same, and that had been the phase margin. How the phase margin is being defined? It's been defined as 180 degree. The angle offered by the system Gj omega Hj omega at omega is equals to of omega Gc. Many of the students might be thinking, sir, why we used to take the reference of omega Gc? Omega Gc is the frequency at which the gain offered by the system is precisely 1. Why we take the reference of omega Gc? Because I want to have a lag in such that this polar plot must be crossing through -1 plus J0. And if we'll talk about the gain at -1 plus J0, how much gain we had? Obviously gain had been precisely 1. So either you can call it omega is equals to omega Gc, or either you can call it a frequency at which the gain offered by the system is being 1. That's it. And see, if we'll be keep providing the lag, what I'm saying, if we'll be keep providing the lag, the moment it crosses through the -1 plus J0, there I would calculate the angle offered by the system, and that would be GH. And how much phase margin we are going to have? The phase margin which we are going to have is going to be 180 degree. Did you understand what I'm saying? If you're not able to understand, do one thing. Focus over the omega is equals to omega Gc. Omega Gc is being the frequency, I repeat, omega Gc is being the frequency at which the gain offered by the system is precisely unity. Obviously, we would be taking the reference of polar plot. So this has been the point where the gain offered by the system is precisely unity, because it had been crossing through the constant unity magnitude circle. Yes. Now what we are going to do? We are going to calculate the angle now. How the angle would be calculated? Angle would be calculated all the way from the positive real axis into the clockwise direction, and this is gonna be this factor. Which factor it had been? This factor it had been. Yes. This has been 5. This has been 5. Agreed? So may I know what had been the remaining component? This has been the margin in phase. If you will be keep rotating it, if the remaining phi is being traveled in the clockwise direction, what would happen? This point would be tackled at -1 plus J0, and system would reach to the critical stability. System would be reaching to the critical stability. Obviously, the system would become an unstable system. So obviously, from where the formula had come, sir, the formula had come from there only. Because just try to understand, this angle is always going to be negative. This angle had been taken positive. And if you'll talk about this value, which one? This one. Which color should I be taking? If you'll talk about this value, this has been the phase margin. I would like to have the input from each one of you. If you really understood the concept behind the phase margin, you should put thumbs up over the live chat. So this has been the angle provided by the system. Why I have taken the reference of -1 plus J0, that you could have understood, because in future if you will be sliding it, this point would be reaching to the -1 plus J0, and this had been the margin in phase, how much phase lag we can provide to the system. So I would say now nobody should have to by heart this formula, from where the concept of the phase margin had been 180 degree plus of the angle offered by the system at omega is equals to omega Gc. I have also seen many of the times the student used to by heart, sir, for while calculation of phase margin, we used to have the reference of omega Gc. Many of the times I have seen the student used to also have doubts, sir, while calculating the PM, why don't we take the reference of omega Pc, and while calculating Gm, why don't we take the reference of omega Gc? That is utterly correct. That is utterly wrong. So this has been the phase margin. So may I know from each one of you, in this particular problem, the worth of the phase margin, has it been a finite value, has it been an infinite value? Obviously, sir, it had been a finite value. How will I get to know about it? Just calculate the phi now. The phi had been the phase offered by the system at omega, at which the gain offered by the system is being simply 1. So what we are going to do? At very beginning, let me focus over the value of omega Gc, because in sequence we would be calculating the omega Gc. At omega Gc, gain offered by the system, it's been √2 divided by of gain of S is simply going to be S, and here it's been omega square plus of 1. May I know at which particular frequency? I think manually you can do it, or with the help of hit and trial easily you would be able to get the value of omega at which this becomes 1. My dear friend, if you keep omega is equals to 1, it becomes 1, it becomes root over of 2, root over of 2, root over of 2 goes off, and hence I can say the omega GC is being simply 1. Omega GC is being simply 1. And I think it's the right time to calculate the value of phase margin, and the phase margin is being 180 degree. Angle offered by this system at omega is equals to omega GC. May I know how much angle it would be offered? Because of S, we would be offered with a minus 90, and here we would be offered with a 10 inverse of omega divided by 1, and that had been 1 only. That would be 1 only. And here it goes 180 degree minus of 90 minus of 10 inverse omega at omega GC, that had been 1. Put together it's going to be 180 minus of 90 minus of 45, and the result what we are going to have is going to be 45 degree. Is going to have as a 45 degree. That means if you will start rotating it into the clockwise direction, or if you have started putting the phase lag into the system, after 45 degree, this point comes to this point, and once you'll go beyond this, know what would happen? The minus 1 plus J0 would encircle, the system would become a unstable system. So in terms of phase margin, obviously sir, the phase margin had been infinity. In terms of gain margin, the gain margin is being infinity. Now I would like to have the input from each one of you. 1 upon S plus 2, and the second system what we had, root 2 into K divided by S into S plus 1. Which system would be the better stable system, or where the stability is being more? I take the reference of both of the system. This has been the first system, yeah, and this has been the second system. Which system had been the more stable system? Here gain margin had been infinite, here also the gain margin had been infinite. Here the phase margin was also infinite, but here the phase margin had not been infinite, it had been a finite value. So may I know which had been the more stable system? Obviously sir, 1 divided by S plus 2 is going to be a more stable system, because anyhow I can keep on putting the higher value of gains, still the system is not going into the zone of instability, and at the same time I can keep push the lag into the system is not going into the instability region. I think this has been the correct option. Let me do one thing. Let me take the next question, and deliberately let me design the problem for you guys. I have taken 2 divided by of S plus 1. Don't touch your copy and pen. I repeat, don't touch your copy and pen, and just tell me what is the expected value of gain margin and phase margin in terms of finite and infinite. I need not to have the exact answer. Just I am checking your thought process, how far you could really understood when the gain margin and phase margin becomes 0. So tell me, out of gain margin and phase margin, which value is going to be finite, which value is going to be infinite? Which value is going to be finite and which value is going to be infinite? Whether the gain margin is going to be infinite, whether the phase margin is going to be infinite, whether partially they are going to be infinite, or whether both of them are going to be infinite. What I would suggest to all of you, draw the Nyquist plot within your brain. You need not to touch your copy as well as pen, because unnecessarily you would be wasting your time. And such a huge amount of practice we had taken, or the practice questions we have taken over the control system. Now you would be more than comfortable drawing these problems. Gain margin is infinite, phase margin is 180. No, that's wrong. Phase margin 180. No, that's wrong. No, that's wrong. Anyone else? The 2 input we have got it so far. Vignesh Vicky says the GM is infinite. Perfectly, the GM is going to be infinite. DS says the phase margin would be 180. That is absolutely wrong. And similarly, Vignesh also says the phase margin would be 180 degree. Absolutely, that's wrong. Just try to understand how I did understood it. So here goes the solution part. Again, let me take the reference of polar graph paper. It's been the imaginary axis, it's been the real axis. This has been the 0 degree ray, this has been the minus 90 degree ray, this has been the minus 180 degree ray, and this has been the minus 270 degree ray. Could you understand what I'm saying? As far as the 2 divided by s plus 1 is being concerned, once you'll feed omega is equals to 0, the gain offered by the system is simply going to be 2. And at the same time, if we'll talk about the angle offered by the system, it's simply going to be 0. That means the starting angle would be 0 degree, starting magnitude is going to be 2, somewhere here. So it is going to be 2 with the angle of 0 degree, with the angle of 0 degree. As the value of omega would increase, definitely the denominator is going to be more and more heavier, the magnitude would decrease. As the magnitude is decreasing, what would happen? This point would start coming nearer to the origin, that is the first thing. And at the same time, the angle offered by the s plus 1 would be tan inverse of omega. As the value of omega would increase, definitely the phase would be more and more lagging. Phase would be more and more lagging. And end of the day, the curve is sort of this. Curve is sort of this. Agreed? This has been 2, 0. Now what we have been doing, this has been minus 1 plus j0. Where the minus 1 plus j0 it would be just at a half of it. It is simply going to be minus 1 plus j0. Anyways, first complete this curve in a form of Nyquist. Here the Nyquist do completes. Now what I would suggest to each one of you, keep giving the gain k. Keep giving the gain k. It would be keep expanding, but it would be expanding in the first as well as fourth quadrant only. That means minus 1 plus j0 has not gone into the danger at all. What does it mean of it? The system remains a stable system even for k goes till very high positive value, and that had been infinity. That had been infinity. Agreed? Even you could have taken the help of Routh-Hurwitz also. See, in Routh-Hurwitz it had been s plus of 1 plus of 2k. If the k had been positive, no, one thing has been quite sure, the pole which had been kept towards right hand side is being 0. Obviously it would be a stable system at any cost. But what had been happening, no, just try to understand, because I know many of the students were doing the mistake because they could not exactly understood the things graphically. What we have been doing now, we have start giving the lag now. See, we have start giving the lag. And we are just focusing when this curve is going to pass through minus 1 plus j0. Minus 1 plus j0. Just a minute. Almost 90 degree lag has been given. And still we have been giving the lag. Still we have been giving the lag. Still we have been giving the lag. And now you yourself would be able to understand. Now it has been passing through minus 1 plus j0. See, the curve was sort of this, and it had been keep lagging there. How much lag had been offered? That you tell me. How much lag had been offered? So the lag which had been offered is somewhere this much. Could you really understood what I am saying? Could you really understood? No? Understood what I am saying? Yes, sir. We can. You could have taken the second thought process over this problem. See, what could have been that thought process? You could have taken the reference of constant unity circle. This has been a constant unity circle. And it had been crossing through your polar plot somewhere here. And this had been the operating frequency omega is equals to of omega GC. Yes, sir, we are able to understand it. And how much lag you can provide? You will be keep forcing it, and this minus this gain 1 would be just passing through the minus 1 plus j0. That much lag we can provide. Anyways, what we would do? We would just connect this line. Yes, sir. We would calculate this angle phi. Yes, sir. And the angle phase margin is simply going to be 180 degree plus of the angle which had been offered by this system. So simply it's going to be 180 degree. You also had to find the omega GC now. You also had to find the value of omega GC now, and once you are done with the omega GC, you would be getting the angle which had been provided by this system, and once you are done with that, you would be getting the finite value of PM. I would like to ask the next thing. Rather having 2 divided by of s plus 1, if you would have had the 4 divided by of s plus 1. Your PM would be unaffected, PM would increase or PM would decrease. I would like to have the input from each one of you. What would be the change over the PM now? Because the gain margin still remains infinity, but rather taking the reference of 2 divided by s plus 1, if you have taken the reference of 4 divided by s plus 1, what do you expect? PM would decrease or PM would increase? Obviously, it would decrease. Why so? See, because the gain factor had been increased, and as the gain factor had been increased, what would happen? It would be more bulgy. It would be more bulgy. Just try to understand this way. It would be more bulgy. And you yourself would be able to understand. If you will talk about, just a minute, yeah, unity circle. So unity circle had been crossing through this point, and you yourself would be able to understand the value of phi had been increased now. Or I can say the larger negative value is going to get subtracted, and hence the phase margin is going to get decreased. Phase margin is going to get decreased. Phase margin is going to get decreased. Still, there are several kind of the problem which had been experienced by the different people in GATE examination. Probably I would not take those questions, but still I would have the one-to-one conversation to you guys. If you guys are having any sort of doubt now, you can ask here. You can ask over here. Sir, how to get better at numerical solving? DS. -1 will encircle sooner as we provide lag, obviously. DS, what I would expect, if you really want to increase your numerical solving ability now, I think work more on your basics. Like in this problem, I did not go into the laborious calculation. I was just sticking to the specific basic requirement of the phase margin as well as gain margin. I exactly know most of the students as well as even teachers, they do not exactly feel the concept of the phase margin and gain margin. What they would do, they would just follow a certain process. Like whenever the gain margin is being asked in the question, they would focus over the phase crossover frequency. With the help of phase crossover frequency, they are going to get the gain margin. But when they get stuck, when you have this sort of problem where the gain omega PC itself is not locatable, and in that case, the omega GC cannot be calculated. And as the omega GC cannot be calculated, the student start presuming, sir, the gain margin is going to be infinity. No idea. And many of the times, even the gain margin could also become infinity. Because few of the questions which we are going to take in tomorrow's class, you yourself would be able to understand, yes, sir, in this particular problem, the phase crossover frequency had not been calculatable. And here the gain margin is being infinity. That means if you keep a very small value of Kno, then also the -1 plus J0 is encircled and the system had remained an unstable system. So I would only and only request one thing. If you really want to improve yourself numerically, better to work over the basics, and at the same time try to have 2 or 3 different methodologies for the same problem. And I expect either you are from electrical, electronics or instrumentation, each and individual problem had got at least 2 or 3 methodologies. And I have seen out of 3 methodologies, at least one method would be comparatively convenient method for that particular problem. As the problem would change, definitely the convenient method would also change. But still what I say, have at least 2 or 3 methodology, then only you would be able to understand the things in a better way. Agreed now? So let me do one thing. Let me take the next question, and this question had brought in front of you. The problem is being experienced by the electronics people in year of 1999. The problem was framed by IIT Bombay. The problem states the phase margin in degree of a system having the loop transfer function 2√3 divided by s into s plus 1. The 4 different options were attached along with this problem. Tell me what would be the best most answer for this given problem. Anyways, what we would do, we would say end our session here itself, and tomorrow we are going to take few more number of problems based on the concept of the gain margin and phase margin. We would bind up the concept of the gain margin and phase margin in tomorrow's class. If you have any sort of doubt, the DS had the doubt, so obviously I had a little bit idea that how we can conquer the problem related to the numerical solving ability. So probably that could be the better strategy. Anyone else apart from the DS? Anyone else? Vignesh, Vicky, I would like to have one thing from you. May I know from which particular region you had been, or from which particular state you had been? DS, may I know from which particular state you have been? The 6th number of student had been live. May I know from which are the different states, or which are the different parts of the country you have been belonging from? Okay, Vignesh, that's great. Tamil Nadu. I had been there for the 5 years in Tamil Nadu. It's a great place, lovely people. DS Chhattisgarh. The word, name itself, no, Vignesh. I had a little bit interference that definitely you must be from the Tamil Nadu, definitely. DS, you are from Chhattisgarh. I think the rest of the people are reluctant to reply anything, but no issue. That is not a big deal whether you had been replying or not. The big deal is we have been teaching in the consistent manner, whether you had been grasping it or not, whether you have been doing the practice, taking the reference of this module which we had for you guys, and whether you are doing good in your GATE examination or not. That makes more sense. Okay then, this is all about the today's class. In the next video, again we would take few number of critical questions based on the concept of the gain margin and phase margin. Agreed? We would take few number of critical questions. Thank you, sir. I have learned the thought process by your teaching, sir. Thanks, dear. Thanks, Vignesh. Nandri. Okay then. Bye-bye. Take care.